Let's start with a short introduction. So, as we all know, the surface observations are the backbone of our weather forecasting. And they provide the fundamental data for the safety as well as issuing the warnings worldwide. Since 1937, when Vaisala first radio sonde was launched, has Vaisala influenced the surface weather observations by providing observation instruments and systems. We have been providing more and more accurate first simple sensors, then towards having visibility, pressure, and present weather sensors during the 90s. And then we also move forward providing the remote sensing capabilities through the radars and lidars. And now we are looking more to the future, seeing what will be coming there. According to the United Nations Official for Disaster Risk Reduction report from years 1995 to 2015, weather-related disasters became increasingly frequent in late 90s, peaking at 401 events in 2005. Here is showing that more than half of the population has been facing the weather-related disaster. And what is concerning is that disasters are concentrated in areas, countries, which has a lower GDP, thus the impact is more severe and causes more long-term consequences. And we can also imagine that this amount of disasters will have a significant economic damage during this reported time. Let's then look at the global megatrends and how they are impacting to the weather forecasting and the surface observation. So the climate change is something which will is changing the weather patterns. We have seen the news, the more and more these extreme weather conditions happening, heavy rain. On the other hand, we have been also fire in Australia and fires in an unusual number of fires. And so there's changes in the weather caused by the climate change. Then also the urbanization is kind of causing challenges as it increases the need for really localized understanding of the weather and protecting the increased number of people and economies. And then what is challenging known for many med institutes that there is a need to do more with the less. So use less resources and do the same thing. Luckily, here the digitalization is helping us. So where we start is that certain types that we want to cover in a certain location. And then in order to kind of achieve that, we need to have the right instrument for these purposes, so which best fits on these purposes for certain observation type. And what is important for these weather instruments, of course, is the accuracy, because the accuracy is impacting on the weather forecasting. Then, of course, the long-term stability is important. Reliability are kind of making easier to maintain and keep system available. So reliability and long-term stabilities are really important also. And then, of course, weather instruments should have a long life cycle so that when you are installing it, you can be sure that you can later on have replacements and so forth. And of course, the life cycle cost is very important. So those instruments should be very, very easy to maintain and reliable. Then if you go kind of further, when we have kind of building up the observation network, we of course need the weather station to build up the whole observation point. And here I would kind of there are many same kind of things needed from the automatic weather stations. So the reliability, maintainability are really important because we want to have a really good data availability. And again, long life cycle is important, and also in overall the life cycle costs, it needs to be in balance so that we are not spending too much time in having the operational cost high. And then when we have built the observation network, we need observation management system for managing these observations. And this kind of observation manager provides real-time observation and status of devices from one central location with the security connection, and connecting individual system sensors and devices to provide automated real-time and continuous monitoring of entire network. This will free up Vaisala to focus on other tasks. So having kind of central automated system helps improving the efficiency and reducing the costs. And this, of course, this observation management should be a scalable, flexible solution so that it fits for types of networks. Also, this observation system, network management system should support autonomous systems and intelligent field devices of different brands. So not only for single brand, but having fit for purposes instruments and supporting that, and to make the system integration point of view. And what then comes for the, it should provide the optimized solution for lifetime to achieve lower operational costs and investments. And what is also important, that it provides accurate information of the network so that experts can quickly fix the problems remotely, even without the visiting the site. So providing the good capabilities for remote maintenance and control. And then this complete automated observation network provides accurate and reliable data for forecasting system, resulting more accurate forecasts for the public. I think this is really kind of crucial for the observation system. Be accurate, reliable, and automated to ensure efficiency. These accurate and reliable humidity and pressure temperature measurements are backbone of the surface weather observations. Then if we look at more about this advanced observation, this is kind of and talk about this kind of multi-purpose optical instruments. Here in this picture you can see having the weather observation station, which includes the rain gauge, distrometer, visibility and present weather sensor, and freezing rain sensor. Those sensors are a kind of traditional way of having these observations. So each observation type has its own sensors. But there is a way to do it more kind of easier or efficient way. So now there is already available sensor from Vaisala, the FD70, the forward scatter distrometer sensor, which can solve many challenges related to this having the many replacing many different sensors, like now listed here, this rain gauge and distrometer and the others. even more parameters can be in the future be covered with this type of optical instrument. These are basic capabilities that we foresee that the smart sensor should have and will provide more value when having these capabilities. Important to notice here is that when we talk about smart sensor, we are talking about sensor that has a wired or wireless local area communication. So it has connection to the close proximity to the observation site. And what makes actually the sensor connected? Then it has a secure wired or wireless internet access for these smart features. So we can remotely access to these smart features and having this kind of machine-to-machine interface for remote communication and maintenance. The definition of edge computing is written here. What it means that we have a device or a device close to the operational point. And what it would mean for the surface weather, it would help. We could have these around the surface observation network and helping with the processing, basic analytics, data cache, and data filtering and optimization, and also having more efficient machine-to-machine communication capabilities. I think this is really kind of known in these IT infrastructures, but in the future or even now, we believe that it's really kind of important and crucial for those the weather and environmental observation networks and for the data. What we in Vaisala we take cybersecurity seriously. We have been, especially now that we are developing new instruments, new devices, new systems, we have been carefully looking at this part because we see that in the future we need to be ready for different kinds of threats and attacks coming from network and so this needs to be in order. Vaisala participate on this hackathon with our actually the device that is under development at the moment, because it was in such a level, in design was such a level that we were confident, okay, we can go in this kind of hackathon and really see how good our kind of cybersecurity protection is against this kind of attacks. What happened to the Vaisala device? It was not compromised. So that is how seriously we are taking the cybersecurity, and you can see those in our future instruments and devices that those you can rely on those. Also in this side, not only that they're accurate and reliable instruments and systems, but also they are safe to use in hostile open networks or even in closed networks. So I actually have a question to you, kind of reflecting what I was presenting today. Are you ready for the future of the surface observations?